So this is the presentation for the quantitative analysis report. So for case study 1A, this is a two-way ANOVA because it has two independent variables being the major type and the year. Okay, so to create a two-way ANOVA table, all of this should be done to follow the steps. Then we'll move on to the hypothesis testing. Step 1 is to list out the independent and dependent variables. In step 2 is to find out the null and alternative hypothesis, H0 and H1. Third step is to come up with the two-way ANOVA table. Step 4 is to come up with the conclusion. The question also asks to compare the p-value to see if it contradicts my hypothesis testing. So if p-value is smaller than 0.05 significance level, the null hypothesis will be rejected. If p-value is greater than 0.05, the null hypothesis will not be rejected. So after concluding everything, all of the p-values are greater than the significance level, hence the null hypothesis will not be rejected, and it does not contradict my conclusion from the hypothesis testing. So moving on to case study 1B, they asked to come out with the interaction plot. So the steps needed are to find the average for these four major type each here, and then follow the rules here, and then interaction plot will be shown. This plot indicates an interaction between the major type and the year. See, the mean initial salary is higher for major type finance and administration in the year of 2020. But however, when the major type is accounting and marketing, the mean initial salary became lower in the year of 2020. So for part C, this is a one-way ANOVA because it only has one independent variable, being the occupation code A, B, C, D, E, and F. So to create a summary and the ANOVA table, all of this should be done. Okay, and then the hypothesis testing is step 1 to come out with the null and alternative hypothesis. Step 2 to list out the level of significance and the critical value. Step 3 to find the test statistics, and step 4 to finally conclude everything. And then to construct the confidence interval, this is the formula needed to be keyed in respectively in order to get this result. So there are three pairs of salary statistical means that differ. These are the three that differ from the rest. Okay, for case study 2A, it is a Pearson's test for goodness of fit Poisson distribution as stated in the question above. So the steps needed is to key in the provided table into Excel, okay, and to sum out the observed frequency, which is 273, and to calculate the expected value of Poisson distribution, we take number of known applications times the observed frequency respectively, and then divided by the sum of observed frequency. Okay, so the expected value will be 1.72. Then the next step will be to calculate the probability from the Poisson distribution. The formula will be Poisson dot this bracket 0, which is the number of known applications, as following. Then A11, which is the expected value of the Poisson distribution, and then false. Do this for each and every one except for the last one. The formula will be different. Will be 1 minus the sum of the first 5 calculation of the probability from Poisson distribution. Moving on, we'll calculate the expected frequency. The formula to be used will be the probability from Poisson distribution times the sum of observed frequency respectively. Okay, so next time will be to calculate the test statistics, will be observed minus expected to the power of 2 divided by expected. Do the same for every column, and then sum up everything to get the test statistics. Step 1 is to come up with the null and alternative hypothesis. Okay, is that The population follows a Poisson distribution and or does not follow a Poisson distribution. Step 2 is to find the significance level and the degree of freedom. The degree of freedom, the formula is k minus p minus 1, k being 6 because there are 6 different type of loan applications, as you can see here, 1, 2, 3, 4, 5, 6, and then p equals to 1 because it is a Poisson distribution, it has to be 1, and then we'll get the degree of freedom of 4. And then step 3, to calculate the critical value, the formula will be chi inverse degree of freedom, chi inverse level of significance, comma, degree of freedom. So step 4 will be the conclusion. And since the test statistics is greater than the critical value, H0 is rejected. So for that, part B, case study 2B, it is a test of independence. We'll first sum up the total for rows and columns. In step 2, we'll calculate the marginal probabilities. The marginal probability formula is column total divided by the sum total respectively for each. Step 3, we'll be calculating expected frequency. The expected frequencies formula is marginal probability times the row total respectively. And then step 4, we'll calculate observed minus expected to the power of 2 divided by expected. Likewise, to sum up everything, we'll get the test statistics here. And then moving on to the hypothesis, to the testing, will be the null and alternative hypothesis. The critical value will be chi inverse level of significance, comma, degree of freedom. To calculate, then we'll find the degree of freedom. Then to calculate the degree of freedom, will be r minus 1 times c minus 1, with r being the number of rows and c being the number of columns. And in this particular question, the rows is 2, as you can see here, 1, 2, and there's 3 columns. And then conclude everything. Since the test statistic is greater than the critical value, H0 is rejected. So for case study 2 part C, which is the last question, the multiple linear equation is y equals to the intercept plus the coefficient of number of family members, x1 minus the coefficient of total monthly working hours, x2, plus the coefficient of home size, x3. x1, x2, x3 is the variable needed to be keyed in for each particular column. And then the correlation coefficient is 0.873. This is how the data is being loaded and how we find out the correlation coefficient. And for part 3, the residuals for all data points is here, this particular row. Okay, so to calculate the residuals, we first need to find the estimated y, which is this. The formula is intercept plus the coefficient of number of family members times a variable which we will use home ID 1 to work out the estimated. Okay, so it will be 3 minus the coefficient of total monthly working hours times the total monthly working hours, which is 82.1, plus coefficient of home size times home size, which will be 1710. And then after this estimated y is calculated for every particular data point, we will then move on to find the residuals, which will be the actual, which is the monthly power usage, minus the estimated monthly power usage, which is this minus this, we'll get the residuals. So my conclusion is, as the number of family members and home size increases, the monthly power usage will also increase. However, as the total monthly working hours increases, the monthly power usage decreases. This can be proven when I compare residual of home ID 25 with a residual of negative 996 and residual of home ID 24 negative 2073. From this comparison, we can clearly see that the number of family members and the home size for home ID 25 is higher than of home ID 24. And then the total monthly working hours for home ID 24 is higher than of home ID 25. Hence, the above conclusion is appropriate, and it is true that the monthly power usage for home ID 25 is higher, as the residuals of home ID 25 is only negative 996, as compared to the residuals of home ID 24, which is negative 2037. This means that the actual monthly power usage is a lot lesser than the estimated one, which proves that as the number of family members and home size increases, the monthly power usage will increase. And as the total monthly working hours increases, the monthly power usage decreases. This can be proven under home ID 24 and 25. Yes. This is all for my presentation. Thank you.